Great to see you here again. My name is Luc de Ceuster, founder of the Ceuster Academy. If you're here for the first time or you didn't subscribe to our channel yet, click on the subscribe button, click on the bell button so whenever we post a new video, you will be informed by YouTube. What we're going to do in this video is to look at the conversion between decimal and binary numbers in both directions. We will start with the conversion from decimal to binary. Binary, we have the base c is equal to 2, so the coefficients can be either 0 or 1, and we have to consider the powers of 2. So basically when we look at it here, I have all the list of the powers of 2, starting from 2 to the power 0, which is equal to 1, up to 2 to the power 9, which is equal to 512. Of course we can continue, but for our exercises this will be enough. First method we're going to do is the subtraction method. Now the subtraction method is a simple method where we are taking the number that we want to convert and base it 10, and we subtract the highest power of 2 smaller or equal to n. And we repeat until 0, until we reach 0. So let's start with the number 99. 99 base 10, well, when we look at it, 99, we have 64 and 128, so we subtract here minus 2 to the power 6, which is 99 minus 64, which is 35. So basically we have here what we found is the first coefficient. We find 1 times 2 to the power 6. The next thing we do, we go to 35, still base 10, and we're going to find the number closer here. 2 to the power 5 is 32, so of course we already subtracted 2 to the power 6, so now we subtract 2 to the power 5. 2 to the power 5, so we have 35 minus 32 is equal to 3. So we have 1 times 2 to the power 5. Now 3 base 10 minus 2 to the power 1 is equal to 1. So we have 1 times 2 to the power 1. And finally we find 1 base 10 minus 1 is 0, and we have 1 times 2 to the power 0. Now what we looked at here, we have this number, we have this number, we have 2 to the power 5 and 2 to the power 6. So basically what we can write here, we start with the highest power from the left to the right. So we have 1, 1, 2 to the power 4 is 0, 2 to the power 3 is 0, 2 to the square is 0, and then we have 1 and 1. And this base 2. Now we can verify how it works. Basically we have 2 to the power 6 plus 2 to the power 5 plus 2 to the power 1 and 2 to the power 0. So that's basically the first number that we in fact used as an example. Now we can do the same for another number. Let's take a different number. Let's have a look at another example for the subtraction method. We look at 321, so 321. We look at the number here, the power of 2, which is smaller than or equal to 321, and that's in fact 2 to the power 8. So I subtract 256, which gives me 65, and that corresponds with 1 times 2 to the power 8. 65, next step, the remainder here, 65, I can subtract 2 to the power 6, which is 64. 64 gives me 1 when I subtract, and I have 1 times 2 to the power 6. And the last one I have 1 minus 1 is 0, and here I have 1 times 2 to the power 0. Now when I write it in a table, it's sometimes a little bit easier. I can say 2 to the power 8, 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, 3, 2, 1 and 0. And I just select the numbers that I had. I have 2 to the power 8, I have 2 to the power 6, and I have 2 to the power 0. So these are the coefficients of the binary number which are in fact equal to 1. So I can say that the number is 1, 0, 1, 0, 0, 0, 0, 0, and 1. So basically our number 321 in decimal is equal to 101. I have 1, 2, 3, 4, 5 zeros, 1, 2, 3, 4, 5, and the final one, binary. The 2 indicates the binary number. So basically that's the method using the subtraction. We will have a look now at the division, the multiplicative solution to find the binary conversion. Let's have a look at the multiplicative method. Here we're going to divide the number by 2 until we reach the 0 again at the end. Basically what we're going to look into are the remainders of the division. So we start with the number 79. We divide by 2, which gives us, in fact, 2 times 39 plus remainder 1. So I have here 39.5. It means that the remainder is 1. We take the 39. 39 divided by 2 gives us, again, 19.5. So we have a decimal here. So we have a remainder 1. We have the 19 divided by 2. 19 divided by 2 is 9.5, which again gives us a remainder 1. Then we have 9 divided by 2, which gives us 4.5, again a remainder 1. And here we have 4 divided by 2 is 2, so we have a remainder 0. We have 2 divided by 2, which is 1, a remainder 0. And the last one, 1 divided by 2, is 0.5, and we have a 1. Now, this is the most significant number, and here we have the least significant number. And we are going to read the number from the bottom to the top. So basically this number will be 79 base 10 will be equal to 1, 0, 0, 1, 1, 1, 1 in binary notation. So basically this system is quite easy also. We just have to look at the remainders. We finish here at the bottom and then we read from the bottom to the top. Let's now do the same for the number, the other number we found, so you can compare them. 321. So when I divide by 2, I find 160.5, which gives me a remainder of 1. Then I take 160. 160 divided by 2 is 80. No remainder. Remainder is 0. We have 80 divided by 2 is 40. Again, a remainder 0. 40 divided by 2 is 20. Remainder 0. 20 divided by 2 is 10. Remainder 0. 10 divided by 2 is 5. Again, a remainder 0. And now we have 5 divided by 2 is 2.5. So we have a remainder of 1. 2 divided by 2 is equal to 1. remainder 0, and finally 1 divided by 2 is 0.5, and we have a remainder of 1. We go from the most significant to the least significant parameter, and we find now that the binary expression of 321 is 1, 0, 1, 0, 1, 2, 3, 4, 5 zeros, 1, 2, 3, 4, 5, and a 1, and the 2 to indicate that we have a number base 2, which is in fact the binary expression of the decimal number 321. What we now have to do is to see how do we get from a binary number, again, the decimal number. Let's have a look at that. To go from a binary to a decimal conversion, we have to see that our number A is written as a set of AI coefficients, AI being 0 or 1. And we can say that the number, this is the number in decimal notation, so we can say that A in decimal notation is the sum of the AI times 2 to the power I from I equal to 0 to n. Now when we look at a binary number, we have a binary number which is, for example, 1, 0, 0, 1, 1, 0, 1. And we have to count what are the numbers here, what is n. In this case, n is equal to, we have 0, 1, 2, 3, 4, 5, 6. So basically what we have to write here, that the number that we want to converts to the decimal notation, is in fact the sum I equal to 0 to 6 AI times 2 to the power I. And what we have here, and we start with the highest significance, so I say 1 times 2 to the power 6 plus 0 times 2 to the power 5 plus 0 times 2 to the power 4 plus 1 times 2 to the power 3 plus 1 times 2 to the power 2 plus 1 times 2 plus, it has to be 0 and 1. So what we have here, we can have a look at the table here. So we have 64 plus 0 plus 0 plus 8 plus 4 plus 0 plus 1. So we have 64 plus 12 is 76 plus 1 is 77 in decimal notation. So the calculation in the other direction is a little bit easier, and we can just use the formula like this. Let's look at another example, so you have at least done 2 examples of the binary to decimal conversion method. Let's take a number 1, 1. Let's have a look at another number, and our binary number is 1, 1, 1, 0, 0, and then 4 times 1. It means that we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. This is 2 to the power 8. So this is 2 to the power 8 is 256. Now here we have 2 to the power 7 is 128. Here I have 2 to the power 6, which is 64. Here I have 2 to the power 5, but the coefficient is 0, so I don't count it. Here again, 2 to the power 4, I don't count it. Here I have 2 to the power 3, which is 8. Then I have 2 to the power 2, which is 4. And here I have 2 to the power 1 is 2. And the last one gives me 2 to the power 0 is equal to 1. So basically what I have to do here is to add all these numbers. So when I look at it, 256 plus 128 is 384. 384 plus 64 is 448. Then I add 8 here. So I have 456. Plus 4, I have 460. 460 plus 3 is basically 463 base 10. So the number here, and I forgot to put the 2 there, but it was clear that we were talking about binary numbers. So this binary number 111001111 base 2 is equal to 463 base 10. So basically that's about the binary to decimal conversion, and this finishes the video about the conversion between decimal, binary and decimal. I hope you liked it. The principle is rather simple, but you have to get used to it. The calculations are not too difficult. You can find websites or calculators where you can do the transformations, the conversions automatically. You can make your own exercises and you can test yourself doing those exercises and verifying the numbers. In Excel it's easy to write a small procedure to do this. Now that was it for this video. Do not forget that below the video in the text you find links to our courses. You find very interesting coupons that you can use to buy the course at a really good discount. Anyway, I hope to see you on my website, and if not, well, you know what happens at the end of the video. Don't forget to subscribe, click the bell button, so whenever we have a new video, YouTube will inform you. Thank you very much and bye bye.